right, so thanks for coming today. So we have another absolutely fabulous talk scheduled for you today in the sales lecture series. This is my cousin, Chris Staubor, and he works for Kindy, and he's going to be talking about the field of AI and how AI is impacting law and intelligence and just our whole lives. So one of the underground things that I'm trying to do with this particular series of talks is get some of you, I know many of you are interested in law or law school after reading your introductions. So I'm trying to get you to think about the idea of tech law, and especially AI and robotics law, which is this massively, quickly growing field where it's just wide open. There just is not a lot of case law already in this area. So you can have massive impact on society going forward for the next few hundred years. So let's give Chris a round of applause and we'll get started.
Thank you, John. All right, well, thank you, everyone. Welcome, and thanks for taking the time to come today. How many of you like to watch The Office? You guys watch that show? I happened to watch it last night, and it turns out Michael was doing a guest lecture at one of the universities, and I promise you I will not do that kind of talk, because I don't think even if you tried you could do that. I mean, it's like amazingly bad. I've been in software for probably more years than I want to count, like something like 37, something like that. I graduated from Cal State Hayward. When we called it Cal State Hayward, I think they call it Cal State East Bay now. And I had no idea what I wanted to do. I was waiting tables to pay for college. I'd started my career as a chemistry major. Went to UC Berkeley for a couple years and realized that isn't what I wanted to do. Realized I had 2 years of chemistry, calc, and physics, and like, what the heck do you do with that if you're not going to go into chemistry? And I didn't want to start over, so I went to a junior college, got an AA degree, transferred into Cal State, and was able to get out in 2 years with a Bachelor of Science in Business and a computer science minor. Still didn't know what I wanted to do in my senior year, and what happened was I happened to be standing at the co-op ed board one afternoon thinking about like what else could be going on. And the guy who ran the program came up and he said, hey, I just left this company and they make computers, they have software, and they're looking for somebody to do backup tapes and be a programmer trainee. He goes, you should apply. I'm like, wow, okay. You know, put things into context. This was like 1982. The computer of the day was this thing called an Osborne. It looked like a sewing machine. I think the Mac Lisa had not yet been invented, and you know, things were kind of old. I went and applied. I got the job. Was there for 5 years. Ended up running a development organization and had a blast. Got recruited to another company that also had manufacturing and inventory and accounting software programs. And actually the first 15 years of my career was spent building manufacturing software systems for a variety of different companies. It was fabulous. It was really fun. And I had no idea that that's what I wanted to do. I left that and actually kind of ran into this little company. At the time there were about 50 people there. They were doing about $2 million in revenue, which you know really isn't that much. And it was run by a guy named Tom Siebel. Anybody heard of him? Okay, good, at least a couple. All right, so Tom Siebel actually created this company called Siebel Systems. And it was the first in a category of Salesforce automation that then joined in with customer and call systems, like those people that call you at night and pester you by selling you stuff. They made those, and analytics, and it created a market called CRM. So we went from about 50 people, 2 million in revenue, and 6 years later we were 8,000 people and 2 billion in revenue. And that's where the gray hairs come from, because I'm really very young. But it was really an exciting time. We created a market, we delivered software products to it, and back then it was all about client-server computing was like the big deal. Left there, helped to co-found a company that built the first corporate tax application in the cloud. And you think, corporate tax, how boring could that possibly be? And somebody actually told me, they're trying to give me career guidance, and they said, you know, tax professionals are the ones that didn't have enough personality to be accountants. I thought, man, that is harsh. That is really harsh. Turns out tax is actually really cool, on the legal side especially. So I think we've got some maybe pre-law folks in here. The legal aspects around tax are incredibly interesting, and there's a ton of money involved in that. So you get, in tax world, you get the accountant part, you get the legal part, and that works out really well. So we built this company. It was software as a service for corporate tax departments to store their files, to manage legal entities, to figure out how things were going. And what happened is we found that we were competing against a couple of other companies, Thomson Reuters being one of them, and they got pretty pissed when I beat them at Verizon. And then they got really pissed when I beat them at AT&T. And then when I took Intel away from them, they got extraordinarily pissed and they bought my company. And so they basically took us off the market. They put all the software on a shelf. They transferred the customers over. It was not fun, but you know, we had a nice little exit out of that. And so from there, I went into this domain called supply chain and logistics. It's the largest single instance of multi-company, multi-enterprise software as a service for transacting products all around the globe. There's about 100,000 different organizations that use it, and they're buyers and sellers like the Gap and car companies and Crate and Barrel, and you know, all these guys, they sell stuff on this platform. Way fun. Was there for about 7 years, and then got into this company called Wynyard. And this was really interesting. These guys were based in New Zealand. So I live in the Bay Area here. I commuted to Auckland, New Zealand for about a year and a half. And what we did basically is we used technology, you know, the webcams and the video monitors and all that good stuff. And I'd do that for a week or two, and then I'd fly to Auckland and hang out with my guys there and in Christchurch, and ran the development organization. And we were building intelligence and law enforcement applications for helping find criminals. And it was either, you know, find them before they do bad things or find them after they do bad things. You know, we preferred the former. But it was all about using information to be able to do good things, right? And so the kinds of stuff we did started to border on things that make people feel creepy, right? So for example, you know, it's not legal to tap somebody's cell phone, obviously, but if you're on Snapchat or Facebook or any of these other things, you already know those companies take your data and they sell it, right? That's how they make their money. So, you know, this, if you've probably heard this before, if you're using a product that you didn't pay for, then the product actually isn't the software, it's you and your data, right? And so that's how Facebook makes their money. That's how Twitter makes it. That's how Google makes their money. They're making it off the data that you have. Well, as it turns out, in a lot of other countries, the laws about privacy are actually quite different, right? In the EU, they're much more strict than they are here, and you have to opt in to have companies use your data and disperse it. Here, you have to opt out of that, and companies automatically can use your data. So at Wynyard, what we were doing is taking data like that, they call that open source data. We would also combine that with data that you could kind of think about getting easily, like if I knew your license plate, I could probably go to DMV and find out what your name is. Can't find out your address, but if I have your name and your Facebook, I can probably find that. If I have your name and your address and your license plate, and I'm a cop, then I probably have access to license plate cameras. They're all over the place, right? Sometimes cities tell you about them. Most of the time they don't. My little town, Danville, it's a small little town. The town council just reported, I think last year, that they bought 6 of them, and they put them like at the freeway off ramps and in the big intersections in there. And these cameras are just specialized cameras that point to the cars, and they take the license plate picture and they decompose the image into the characters, and then just take a snapshot of that. And you think, well, gosh, that seems kind of creepy, seems like an invasion of privacy, but you're in the public forum, you're on a public street, and so it's kind of okay. But now that I got that, if I have your license plate and I know where you were, then the other thing I can do is I can now coordinate what cell phones were in that area at that time. And so now I can connect your license plate, your car, your name, your address, your cell phone number. If I got your cell phone number, then there's all manner of stuff on these little devices that you can also capture. And so what we did at Wynyard was we wrote software. We didn't run it. We sold it to the police forces and the intelligence agencies and a lot of other countries, but also here in the US, like the Ventura County Sheriff's Department used our stuff, and the Atlanta Bureau of Prisons. And you ask yourself, Bureau of Prisons, what kind of crime happens in a prison? You'd be surprised. There's a lot of crime that happens in prisons. And so we were using that technology to actually stop criminals. We gave a gratis version of this to the World Wildlife Federation and to, who's the other guys? There's an organization that is trying to prevent people who do human trafficking, and we would give the software.
At the beginning of our lecture series, we had them give us.
Oh, cool. Yeah. Very cool. Yeah, so we were given the software way for those kinds of people, because this same technique work, whether you're trying to traffic humans or whether you're trying to traffic drugs or rhino horns or whatever the case may be, and we use the technology to try and help them do that. None of that stuff was artificial intelligence, though. That was all just like good basic software, big data, analytics, and that kind of stuff. Here at Kindy, we're taking those same concepts and we're kind of upping the ante, and we're also applying them to a lot of different other types of problems that are both legal and intelligence, as well as good old-fashioned business and commerce types of things. So there's a term I used up here that actually is really becoming controversial, and it's explainable. It's like, do you know why I'm here? You don't, but you might want to. Yeah, by the way, I forgot to warn you, I pick on people in the audience. It's just my style, and then picking on it in a nice way. But people often want to know why things happen. And it turns out with computer software, a lot of times you get into these situations where the computer makes some recommendation and you want to know why, right? Well, the most prevalent artificial intelligence is something called machine learning or deep learning, and it's a statistics-based algorithm that actually is very difficult, almost impossible to figure out how it makes the decisions that it makes. And you think, well, but if I'm trying to figure out, is this a picture of my mother-in-law or my brother, and the machine learning figured that out for me, why do I care how it did it? And in that particular case, you probably don't care that much. But what if you applied for a job and you knew that the person who actually got the job was less qualified than you, had a lower GPA than you, didn't work as hard as you, but somehow they got that job. And you find out that the company was using artificial intelligence to match candidates with the job openings that they have. By the way, you know that's going on right now. Right now, there are many companies that are actually doing that. Okay? So if the machine learning algorithm made that selection, don't you think maybe it's not fair? Don't you want to know how it picked what it picked? And I think what's happening is that industries are figuring out you can't just do it and say, well, the software picked it, because you actually have a legal liability now to justify the answers that you have. And so that opens up the possibility for what's called explainable artificial intelligence, or explainable AI, which really is a methodology for having the computers make decisions, but making them transparent so we can see what the heck's going on and understand why things happen the way they did. All right, so got to ask the question, what is artificial intelligence? And the funny thing about AI is that there's a lot of money, there's a lot of interest, it has a lot of promise, so people run away with what it means. And they want it to be there. And people slap AI and they slap machine learning on almost everything. And it's like, oh, I got AI enhanced telephones, AI enhanced glasses, and whatever the deal is. And it's kind of funny, but you see this happen all the time in software especially, but in lots of markets. It's just cool, right? Now it's cool to have AI. And so there's this guy named Michael Jordan, not the basketball player, but he's a professor at UC Berkeley, really cool guy. And he goes, artificial intelligence is, could be like Skynet, right, in the movies and the Terminator stuff. That's one way people think about it. Or it's technologies like search engines and natural language processing, right, and be able to look at language, figure out what it means, and then go do something useful. Like if somebody asks a question, and then go figure out what the answer is, or go search for that answer. And that's actually what my company does. And then the other one is using the intelligent infrastructure, like the Internet of Things, as it's called, to be able to do interesting things too. And one of the guys at General Electric, right? So General Electric has a digital business unit. It's based down in San Ramon. And those guys are spending hundreds of millions of dollars writing AI for the Internet of Things. And what they're trying to do is make it a little cheaper to keep turbine engines, wind generators, trains, elevators, other infrastructure equipment running at their optimal capacity. And you could send Fred with the overalls and the jeans and the bag of tools to go check that out. Or you could use artificial intelligence and big data to figure out when it's likely to have a failure or when it's likely to need some kind of maintenance. And looking at the data that's there, figure out when that service needs to happen. And so, when I talked to the president of that business unit, he says, Chris, it's really boring stuff, but if we just save that much on the maintenance for all the equipment that's in the world, it adds up to hundreds of billions of dollars in savings. And it's like one of those things that you think about is like how many things, the doors, the elevators, the trains, the freeways, the pumps that keep the water, if it ever rains here again, off the freeways. It's like incredible amount of equipment and stuff. So that's one of the other things that AI is all about. And so now you think, all right, so Michael Jordan figured this thing out. Everybody agrees on what AI is, right? Yeah, not so much. It turns out there's this guy, Andrew Ng. Have you guys ever heard of him? Down at Stanford University. What's funny is when I hire new programmers and they say, I have machine learning background, 8 out of 10 of them, their machine learning background is they took a Coursera class by Andrew Ng. When I was looking for my last job, I took that same course. It's actually a pretty good course. But Andrew Ng's an interesting guy. You can see his creds there. He worked on Google Brain and a number of other things. And his statement is, if a typical person can do a mental task within less than a second of thought, we could probably automate that using AI. It's kind of an interesting thought. It's a little bit of a scary thought. And there's a counter to that by a guy named Gary Marcus, who's out at the New York University. And his statement I love: if a typical person can do a mental task with less than 1 second of thought, and we can gather enormous amounts of directly relevant data, directly relevant, that's important, and we have a fighting chance so long as the test data aren't too terribly different from the training data, and the domain doesn't change too much over time. All right. So what Gary's statement really is about is that you got Andrew Ng over there saying, hey, if we can think about it, then we can automate it. Looking at a puppy or a bagel or a sheepdog or a mop. You guys familiar with that? You ever seen that meme? Oh, you got to look it up. When you get out of here, go look up puppy or a bagel, and then you'll find there's like 7 or 8 of these things. And basically what they are, they're images of those things, images of puppies, images of bagels. And it goes to show you how those images look so frighteningly similar that it's very hard for machine learning to separate them and tell them apart. It's just kind of an interesting mind bender, because as you go to Facebook and you see how people tag people in there or Snapchat or whatever, then you think, wow, there's some real sophisticated software going on. So you got Andrew on the one hand saying, if you can do it in a second, then we can automate that. We can use AI to do it. You got Gary saying, yeah, not really so much. Anybody here use Siri? Google Home? Alexa? You guys just shy or embarrassed, or it's not really? I would have thought almost everybody used at least one of those things. I mean, on the way here, I made 4 or 5 calls because it's like an hour drive or so. Okay, Google, call my mom. No, don't do that. But those things, they seem a little creepy. They seem pretty advanced. They seem like they can do some really cool things. In reality, it's a very narrow set of things that they can do, and they're pre-programmed to do them. So they're listening for keywords. They're listening for a very well-defined set of things that you can ask them. And when it detects that you do that, it actually will do that job for you, which is really nice. What we'd like to be able to do is actually do what I'm really asking, do what I'm really thinking. And that gets into what natural language processing and natural language understanding is all about. And the kinds of things that people want to do with this now go from every industry, every vertical, government, commercial, nonprofits, pretty much every walk of life. It turns out that more than 80% of the world's data is unstructured. And what I mean by that is, structured are things like Excel, or in a relational database, or in a Cassandra or Hadoop system where you have rows and columns or value and tags and things like that, very structured data. Unstructured are things like your Word documents, your Google Docs, the PowerPoints, the just free-form text, the chat stuff. That's all unstructured text. So 80% of the world's data is actually unstructured data. 97% of what analytics, big analytics or big data is all about is focused on, you guessed it, the structured data. And the reason is not very many systems can figure out what the heck's in the unstructured data. And it turns out you think it wouldn't be that hard of a problem here in 2018, and with all the science and computer science and people working at these problems, you'd think it would be pretty easy to do. It is not. One of the things that I learned about this when I got into this business was the challenges associated with things as mundane as Adobe PDF files. You guys ever use, or you run into a PDF, right? And you find something interesting on the web and you go, oh cool, I'm reading this PDF and let me just cut and paste that text into some other document. About like 2/3 of the time that doesn't work, right? It's screwed up somehow, the characters are weird. Turns out PDFs don't actually store characters, generally. They store images of characters, or what we call glyphs. And so when you're actually cutting and pasting, if it works, somebody did some magic to turn those images actually into characters. So something like, I don't know, out of that 80% of the world's data, 45% is actually in PDF form, because people scan stuff and then it turns into a PDF image and whatnot. And so you got all this data that's stuck in these silly forms, and you can't actually pull the text out of them. So you have to OCR, or optical character read, to turn it into text. Now that you got the text, you got to figure out what the words mean and how they relate to other things, right? And so that's the key. And so in pharma, the things that we're looking at here are to be able to help pharma organizations and the FDA figure out how to get better use out of drugs, how to find correlations between side effects or undesirable, how to apply benefits to drugs that weren't necessarily on label, but they find out later that it's good for it. So like there was just something recently about a diabetes drug that turns out to be really good for lowering blood pressure. And that isn't the way the research went. Somebody did research on diabetes, they came out with some drug, it helped them out, they're doing studies on that, they released it to the public, and then it turns out like, wow, it lowers blood pressure too, who knew? And so the way that you figure that stuff out is you go through what's called clinical trial records. And those records would be somebody came in, they had a dose, they were a certain date and time, here's the patient's name, here's where they came, here's the doctor, and then here's what the patient said, here's what I recorded, here's some other stuff in that unstructured text. And so what we're doing is we're applying natural language processing to go read that unstructured text and then find out the interesting things and how you correlate it. And where the artificial intelligence or machine learning comes in is that it turns out people don't use the same words, they don't use the same terms, they don't speak the same languages, they don't use the same grammar, they don't use punctuation consistently, and you guys know all the rest of that, right? So just go read an email or read somebody's Snapchat, you find out it doesn't have any of that stuff. And it turns out doctors and lab technicians are notoriously bad too. Patient arrived, shortness of breath, seemed concerned, high anxiety, recommended more sleep. And it's like, that's it, right? There's not a lot of nouns and verbs to construct what that language means. And so what the software does is it figures out those patterns. It tries to apply what we call part-of-speech tags. So we look for nouns, verbs, predicates. We then look for special kinds of things, like we look for people, places, names of items, objects, drugs, those kinds of things. And we tag them in a special way. And then we create a graph representation of that. And so that's what that one's all about. The other side of the coin is the FDA's version of this. And it's not just the FDA. The World Health Organization came out with this thing, and it's always really hard for me to remember the word, pharmacovigilance. And what it's all about is trying to make the whole drug environment a lot safer. Right, because people are using drugs for a variety of things. Today we have more drugs available, legal drugs available for us for any manner of disease. The challenge, of course, is, are they safe? And are they safe not just in general, but are they safe for you, or for you, or for you? And it's hard to tell, right? So that last slide where we were talking about clinical trials, if you look at the little colored part of the diagram, they talk about phase 1, 2, and 3, and you'll notice the number of people in those trials gets dramatically bigger. But, those are still in the thousands versus, how many people live in the U.S.? I forget the number. It's
235 million, something like that.
235 million? That seems like a lot. So if we're doing a trial with a few thousand participants, you think they catch everything? I don't think they do. I think they catch a lot of things, but they don't catch everything. And so what pharmacovigilance is all about is capturing information around the globe, really, on the use of pharmaceuticals, the implications, the indications for what the pharmaceuticals were used for, and then trying to ensure that they're actually safe and don't have a lot of side effects. And of course, it's really, really hard to do that because people are very, very different. Their diseases are different. The method of taking the pharma is different. So you got all these different variables in there. But instead of just saying, that's too hard to research, what people are now starting to do is to use natural language to capture the things that have been recorded and look for commonality. Or the reverse of that is you look for the anomaly. And so there's a mathematical technique. Anybody here in stats? Stats, economics, yeah, you probably hated that part. Clustering techniques is what they are, clustering algorithms. And so you get data points and you're looking for, do they all group in one place? And if they do, it's usually like 90% or 95% maybe group in this thing, and then you got random guys that are off in the edges of the picture. And you're looking for, okay, why are those guys out there? And because that tells you something, right? Or you're looking for where the clusters are, because that also tells you something. So that's what pharmacovigilance is all about. And then the last thing to talk about is our friends at the Department of Defense, right? Our good old DoD guys. And it's September 11th. It dawned on me this morning. It's like, oh yeah, I'm gonna go give a talk about this stuff, and it's September 11th. Just remember what you were doing on that day?
the son might not have been born.
Yeah.
They were
That's
very-
right. It says 20
Yeah,
year.
they were
Yeah.
infants. Yeah.
Yeah. So I live in Danville and I work in San Mateo, and there's this really long bridge that goes between those two things. I had relatives that were over at the house. They were going to get on an airplane and go back home that day. And so we got up early, we were watching the news, and you see this stuff, you see the planes, screaming into the towers. I didn't want to go across the bridge. I thought, hell, I do not want to drive across the bridge, because if they blow up something, it's going to be really hard to get home. My family will be on the other side and stuff people did like a lot of weird stuff that day. The DoD has similar problems that commercial enterprises have in understanding the data. And what I learned recently is that the DoD, in all its massiveness, there's all these different branches, right? You got the Army, the Navy, the Marines, the Air Force, and I guess the space agency's coming. And then, I shouldn't do politics, right? Yeah. And then you've got all the secret organizations, the FBI, the CIA, the NSA, and there's dozens of other ones that we normally don't hear about much, but they're all over the place. Every one of these organizations has ways of collecting information, and they have intelligence analysts that monitor this stuff. So part of what the Air Force does is they do have satellites. Satellites take pictures. They have people that look at the pictures. They have software that looks at the pictures. Bless you. They have software that looks at the pictures and tries to find things that are interesting, and when they find interesting things, they give them to the people. They have people on the ground. They have spies. They have all this stuff going on. Every one of those agencies takes that data and they summarize it for the next level up the chain of command. And eventually what you get is date, time, analyst, agency, bunch of other stuff, classification, whether it's classified data or not. And then you get some text that is like, observed these equipment movements happened at 1200 and 1 hour later these other equipments moved in a different place. We noticed this many personnel there, blah blah, whatever happened, and it's in text. And so what's going on now is the Joint Chiefs of Staff, who are the guys that are at the top of all these agencies, are now trying to apply artificial intelligence to figure out if there's stuff of interest there. And you probably even heard about one of the programs because it was in the newspaper a lot, because some folks at Google decided that they didn't want their company working on that stuff, right? And what's interesting is that, if you talk to people in the Department of Defense, their explanation is, we're trying to save lives. That's what they're about. They're trying to save lives. They're trying to prevent bad guys from doing bad things. They're trying to prevent war. They're trying to notice changes before an adversary is able to commit some other future badness. And so, it does turn into this little ethical dilemma about, are you helping the good guys or the bad guys when you're helping the DoD do things? I have my personal opinion, and that's why we're working on this stuff. But they basically have the same sort of problem. They have all this unstructured text, and you want to be able to figure out, what does it mean? And so you're looking for, using artificial intelligence to look for words. And it's not just, because like you would expect, the bad guys don't say, we're going to put the IED bombs on the road at mile marker 24 and light them off at 2 o'clock in the afternoon. They don't say stuff like that. They might say, we'll pick up the papayas and they'll show up, at the party at 5, and they use code words and they use different kinds of things. And so that's where those clustering and algorithms and the anomaly detection really come into play, is that they give you an ability to actually look for things that are out of place. And so that's some of the work that we're doing with these guys. So that's the end of the slideshow. What I thought would be useful is to see what kind of questions you have and what kind of discussion you want to have about artificial intelligence, about military, or anything else. Yes, sir.
Yeah. I was wondering if you could relate any of this to the whole problem of syntax versus semantics. An awful lot of critics of AI say, well, you know, computers can only do syntax, they can't do semantics. You can only talk about how the words relate to each other, not how the words relate to the world. Do you think that the work you're doing, given that it's dealing with natural language, the way people actually talk into the world, do you think you're actually dealing with something like semantics? Do you think you managed to cross that bridge? Or what?
Wow, that's a very insightful question. Yes. So yeah. So anyone use Google ever? Yeah, of course you have. You ever find how uncanny it is that it figures out what the next word's going to be or the next letter that you type is going to be? It's like amazingly accurate. And it uses an algorithm called word2vec to do that. And what word2vec does is it does a combinatorial matrix, and basically, if you think about it, it takes every word by every word, and then it calculates the frequency that those two things are next to each other. Right? So it creates like a big spreadsheet and puts the number of occurrences in there. It really compresses that into another representation of vectors. But essentially, that's what it is. It's a combinatorial matrix, and it gives you a statistical probability of a letter or word being the next one. And that is purely the syntax evaluation. So it doesn't actually know or care what the meaning of the words are, but it does know the probability of the next one being there. If you look at things like words that are antonyms, then you can see how this gets fooled up. Because if you look at word2vec, the word good and bad are syntactically exactly the same. You can take any sentence where you use the word good, you can replace the word bad in there, and it turns out to be syntactically identical. Semantically, it's 180 degrees apart. What we're doing at Kindy is we do use algorithms like that, but we do something, we call it the semantic distance field model. And it's a fancy name for calculating the semantic distance between two words or concepts. And we use a couple of external lexicons to do that. So if anybody ever heard of WordNet? You ever seen that thing? Okay, so WordNet's something you can go online and go look it up. And it's actually much more sophisticated than a dictionary or a thesaurus, but it shows you synonyms, you know, words that mean the same thing. It shows you hyponyms. So car is a good word. Honda Accord is a hyponym of car. It's a more specific word. A hypernym would be a more general word like automobile or ground transportation. And so WordNet is a representation that gives you the relationships with words, but it only covers a small fraction of the English language. And it turns out if you point that at, say, pharma or DOD or social media or something else that's like formal written English words, then it starts to fall apart. The uniqueness of the Kindy technology is that we read the unstructured text, we create a semantic distance field model, which is a big graph that has all these relationships of the words, and we use things like WordNet and other ontologies to induce a field that really gets the meaning of the words and creates this distance measure between them. With that, we now have a better understanding of how two words or concepts or terms are related, whether they're very similar and tightly connected or whether they're very far apart and not connected, and what else they are connected to. And so that's where you start to really get the meaning, is not just do I have a word and what are its synonyms, but what else is that word connected to in my network graph? And that's where we can now start to uncover some hidden meaning in that. And so, yeah, that was a cool question.
It's pretty close to being semantics.
Yeah, I mean, Now can it really tell the meaning or the intent behind?
Another word.
Yeah.
It's still not like the word is like reaching out and grabbing reality, which is sort of what we wanted to do.
Right, that's exactly right.
Well, yeah,
early in that philosophical debate, between syntax and semantics, and some people saying that we'll never capture semantics, but there was this school of thought that well, just enough syntax just is semantics, right? And so what we're seeing now with AI technology is that it's great at syntax, and it's getting so much better at syntax that what's bubbling out of it is something that kind of eerily feels like semantics, right?
Yeah, it's. I think a good analogy is actually looking at Siri or Google Home or any of these other things. If you really experiment and push them, then you find out how weak they are. But they give you the impression of really knowing what you're asking for. And I think the more that you get AI to improve on these algorithms, then you start to creep in that direction, as you say. And what we've found, first of all, our algorithms are based on a guy who invented this thing called the knowledge graph. This guy named John Soa lives out on the East Coast somewhere. He's on our board of advisors. And I think he invented it like 18, 20 years ago, which is kind of old. But it's a conceptual graph, and it talks about how concepts of being on top of or near or next to, how those can be related and represented symbolically in a graph structure. And that's really the fundamental basis for what our architecture is, which is extraordinarily different than machine learning, deep learning algorithms, right, which are using hidden networks of probabilistic computations. And so that's where, what we're finding now, we don't yet have production customers. I've been with the company for a year and a half. We're just about to go public with the software, a couple new companies. And what we're finding in the marketplace is people say, they look at what we're doing, they say, wow, that's really novel. That's really, really different than what everybody else is doing. But it's yet to be proven that we can actually get better results. But so far, our early tests show that we will. Yes?
So before you were talking about AI going through a wealth of information that would be practically impossible to manually go through and analyze. So I was wondering, in that scenario, is there a fail-safe?
Yeah, that's a good question. And the answer is probably no. If what you mean by fail-safe is, did the computer miss anything that I would be interested in? Or did the computer miss something that is actually very important? The only way you can do that is if you actually go back and have a human evaluate it and tell you the answer. And herein lies one of the value propositions and one of the differences between our technique and other techniques. Machine learning in general requires large volumes of labeled data. And that's how it figures out how to evaluate something, whether it's an image or whether it's text or whatever the case is. But it needs large volumes of labeled data. And by labeled data, I mean you tell it whether the answer is yes or no or correct or incorrect. And you let the system process large volumes. And by large, I mean millions or tens of millions that enable it to be trained sufficiently that you can then give it another new sample and it should be able to figure out how to classify that, right? So that's basically how that works. The problem is, in a lot of situations, you don't have large volumes of labeled data. Or you could, it just would cost you either time or money or both, right? So if what you're trying to do is in this arena, in the DoD, you get new information from something, you want to be able to act upon it very, very quickly. And you can't necessarily, well, here, let me go get 10 million other copies of that kind of thing, train my algorithms on it, and then see what this one means. You just can't do that. It's not feasible. And so part of what we're trying to do is to create a symbolic representation that allows us to avoid the need to have large amounts of training data. Because of that, it means, and also the machine learned stuff, none of these things are perfect, right? And so to have fail-safe would mean that you never make a mistake, or if you make a mistake, you would be able to figure out that you made a mistake. And I think that's only knowable if you already know the answer. Right? And so unfortunately, I think no. The answer is there isn't a fail-safe, which is personally why I would never use any of this stuff to like do automated weapons or anything like that, right? Because they don't. Yeah.
So I have a question about applications of this work. Since a lot of the interest in here is with the legal profession, when I was in college, I had a job where I was a researcher, right, for a couple of lawyers, and I'd go in and try to whatever cases they were try to find similar cases so that they could use them in their building their case. Can this kind of thing that you're working on in Kindy be useful in that realm?
I think so. There's a number of use cases where you're not interested in the specific words that somebody uses, but you're interested in the intent or the relative meaning of what those things are. And one of the applications that goes across almost every industry is compliance, where you need to comply with a certain clause, you need to comply with a law, or you need to have some kind of disclosure, and the actual terminology is less important than the fact that you have a disclosure about your right to terminate the contract within 36 hours for, I forget what they call that, but there's a certain word for it, where you buy something and you just like you get home, you decide you didn't really mean to.
Yeah.
There's a certain word for that, legal term. Come on, no help, no help.
These guys should know it.
Whatever it is, you want to be able to make sure that any contract that you have has that in it. And one of the things I've learned about businesses is that you think, oh, how hard could that be? You get your lawyer, you make sure that they put it in the template, and all your contracts have that, right? And then your company grows a little bit, and you're like, oh yeah, let's go buy this other company. And it turns out that other company, they weren't so diligent about how they wrote their contracts. And it turns out they had a part-time lawyer that actually didn't know what he was doing. And you buy another company, and they did their stuff all offshore, and they didn't think you needed to do it because it was a different kind of case. And now you end up with this hodgepodge of contracts, and you have no idea what's in them. And so that's where we were thinking that the technology that we use to actually look at the language and what its intent and meaning is can be used as a way to fingerprint whether those clauses are in a particular contract or not. And we're doing things with some financial organizations that are also things that seem like they'd be really easy. Like you would think that your bank, if you took out a car loan, would kind of have some kind of form, and it would say borrower, and you'd have your name in there, and so that if the bank could go and look in their system and find out, well, how many car loans did Mr. Sullins take out? Except that same problem exists where the car loans usually are originated at the dealers, and the dealers, right? Those, like, sometimes they're reputable, sometimes they're corner lots, sometimes you buy cars from a friend, and so your contracts are, all over the map, and they don't really know. And so one of the projects we're looking at is looking for words like borrower, co-borrower, and then finding the piece that goes next to it, so that we could then take that and put it in some structured representation so that you could look when he comes in and tries to get another car loan, you say, aha, we already find you on 6 other ones here, no more cars for you.
So one thing I have that just while you're up here to use you for my own benefit, so I'm interested in ethical reasoning. Ethical reasoning is notoriously fuzzy, right? It's of all the types of things that we do with our language, that one we're always sort of speaking around what we really mean to say. So would this kind of software be good at helping machines understand when they're dealing with ethical claims that are notoriously weird and from left field?
Not without a lot of additional work.
Okay.
So I would suggest that the ethics question and the understanding of ethics in both a formalized way as well as something that you could assert or make analogies of, right? Because essentially you want to make analogical reasoning.
Right, exactly.
The technology is good for analogical reasoning in general, but as you make it fuzzier and fuzzier, then the kind of matching that you're going to get is more and more difficult.
Yeah.
And so it's not an area that we're currently pursuing. And I think it would take a lot more grinding to make that work.
We need an algorithm that can transform an is into an ought.
That's right. That's what we need, for sure.
Yeah.
Well, great, Bob.